Hello friends, welcome to sidschemistry and welcome to the show Crack the 7. Today's show is Alkenes Love Addition Reactions. Alkenes are unsaturated hydrocarbons. Their general molecular formula is CnH2n. They contain at least one pi bond in the carbon chain and this will induce unsaturation. They love addition reactions. When addition reaction completes, the pi bond justifies, pi bond becomes saturated and they will produce saturated hydrocarbons. Alkenes follow addition reactions like Markovnikov's rule and anti-Markovnikov's rule. They are wonderful reactions and useful in many conversions and in many industries to prepare a range of organic compounds from the alkene. So Markovnikov's rules are very important, and if you want to twist a change in the product, then we have to induce anti-Markovnikov rule, which is just opposite to Markovnikov's rule. Alkenes show geometrical isomerism. It means cis form of alkene and trans form of alkenes are present in the nature. Trans forms are more rigid, they are compact structures and they are tightly arranged in a crystal lattice. Therefore, their melting point is very high. All alkenes are non-polar compounds and soluble in non-polar organic solvents. Lower alkenes, it means less number of carbons, are gaseous in nature. When the carbon chain increases, alkene become more and more liquid and then after they become solid. When we talk about the applications of alkene, alkenes are very important starting material for the production of range of organic molecules and polymers. They are the key ingredient to start the polymerization reactions. This is all about the briefing of the alkenes. Now let's start the show. We will solve key important MCQs of alkene. Enjoy the show and gain the knowledge. Crack the 7. Now presenting very first question of the show, question 1, level 0, and the question is: identify the molecular formula of alkene. Options are A, C3H7, B, C2H8, C, C4H8 and D, C3H8. Dear friends, alkenes and alkynes are hydrocarbons. Their general molecular formulas are CnH2n plus 2, that is for alkane, CnH2n, that is for alkene, and CnH2n minus 2 for alkynes. So the correct general molecular formula with refer to the alkene is CnH2n, and when we see the options, the correct combination sets for the option C, that is C4H8. Whatever number of the carbons are present, double the number of hydrogens are present, and that is the correct formula of alkene. So correct answer of this question is option C, that is C4H8. Now presenting second question of the show, question 2, level 0, and the question is: the solubility of alkene can be represented by. Options are A, insoluble in non-polar solvent, B, insoluble in water, C, soluble in water, and D, soluble in polar solvents. Dear friends, alkenes are non-polar compounds. They are non-polar hydrocarbons and therefore they are not soluble in polar solvents like water, methanol, ethanol. Now when we see the organic solvent compositions, organic solvents are non-polar compounds. Alkenes are also non-polar compounds, and that is a fact that likes dissolve likes. Therefore, alkenes are soluble in non-polar solvent, but they are insoluble in polar solvents like water. Now let us see the options. Option A says that it is insoluble in non-polar solvent. No, they are soluble in non-polar solvent, so option A is incorrect. Option B says that it is insoluble in water. Definitely alkenes are insoluble in water because alkenes are non-polar compounds and water is a polar compound. So this option is a correct answer for this question. Option C says soluble in water. No, they are not soluble in water because water is a polar solvent. And option D says that they are soluble in polar solvent. No, they are again not soluble in polar solvent because alkenes are itself non-polar compounds. So correct answer for this question is option B, that is insoluble in water. Now presenting third question, level 1, and the question is: alkenes are called as blank compounds and mostly they show blank reactions. Options are A. Unsaturated carbohydrates addition reactions. Option B. Unsaturated hydrocarbons addition reactions. Option C. Saturated hydrocarbons substitution reactions. And option D. Saturated carbohydrates substitution reaction. Now there are 4 different terms to understand here, that is unsaturation, saturation, addition reaction and substitution reaction. First of all, let us understand unsaturation. Unsaturation is a kind of property where pi bond is present in the molecule. Saturation is a kind of property where pi bond is absent in the molecule. When pi bond is present, addition reactions are preferable for that molecule, and when sigma bonds are present, I mean to say pi bonds are absent, substitution reactions are possible. So alkenes are unsaturated hydrocarbons because they contain at least one double bond anywhere in the chain of the carbon, and therefore they prefer addition reactions. Their most favorable reactions are addition reaction. So looking at the option, correct set of the answer is unsaturated hydrocarbons and addition reaction, and therefore the correct answer is option number B, that is unsaturated hydrocarbons and addition reactions. Now presenting fourth question of the show, question 4, level 1, and the question is: alkenes show unique property of isomerism which cannot be shown by alkane and alkyne. The name of this isomerism is, options are A. geometrical isomerism, B. chain isomerism, C. position isomerism, and D. isomerism cannot be shown. Dear friends, isomerism is a kind of property where the molecular formula remains same but the structural formulas are different. When we talk about geometrical isomerism is specific to alkenes. Geometrical isomerism of 2 types, cis form and trans form. Cis form and trans form have different physical properties, and therefore this is a very important properties of the alkenes. These properties cannot be shown by the alkenes and the alkynes, and therefore the correct answer for this question is option A, geometrical isomerism. Now presenting fifth question of the show, question 5, level 2, and the question is: a special addition rule signifies most of asymmetrical alkene reactions. The name of the rule is blank. The rule adds the electronegative species at the double bond containing carbon having blank number of hydrogen atoms. Options are A. Markovnikov's rule, less number of hydrogens. B. Sidschemistry's rule, less number of hydrogens. Option C. Markovnikov's rule, more number of hydrogen. And option D. Sidschemistry's rule, less number of hydrogen. Dear friends, let me introduce Markovnikov's rule. Markovnikov's rule is a special and unique character identifies for the asymmetrical alkene molecule. Whenever asymmetric alkene molecule is present and whenever a attacking molecule having electronegative element is reacted with the asymmetric alkene, the electronegative part of the reagent will attack on the carbons having less number of hydrogen, and that carbon must contain double bond. It means it is ethylenic carbon should be there. So correct answer for this question is Markovnikov's rule, and it will add the electronegative species to the carbon which has less number of hydrogens. So correct answer for this question will be option A, that is Markovnikov's rule and less number of hydrogens. Now presenting sixth question of the show level 2, and the question is: the melting point of which kind of isomers are high in alkenes? Why? Options are A, cis isomers due to more hydrogen bonds. B, trans isomers due to more hydrogen bonds. C, cis isomers due to compact packing in the crystal lattice. And D, trans isomers due to compact packing in crystal lattice. Dear friends, as I told you in the previous question that alkenes can show geometrical isomerism. Geometrical isomers are two types: cis form of isomers and trans form of isomers. Cis form of isomers means similar groups across the double bond are present on same side, and trans form means similar groups across the double bond are present in opposite sides. When trans form of arrangement is present in alkenes, the molecule can come closer and they can tightly pack in the solid crystal lattice, and therefore when they come closer the melting point is high due to tight packing. So the correct answer for this question is trans isomers, and this is due to the compact packing in the crystal lattice, and therefore the correct answer for this question is option D. Alkenes cannot form hydrogen bonds, and therefore hydrogen bonds is not the correct answer for this case. Now when we see the options, the correct option for this question is option D, trans isomers, and due to the compact packing in the solid crystal lattice. Now presenting seventh question of the show. Question 7, level 3, and the question is: ozonolysis, complete combustion, and oxidation with Bayer's reagent are various reactions of alkene. What are the major products after the completion of each reaction respectively? And options are A, aldehyde ketones, carbon dioxide, glycol. B, aldehyde ketones, carbon monoxide, glycol. Option C, carboxylic acid, carbon dioxide, glycol. And option D, aldehyde ketones, carbon dioxide, monohydric alcohol. Dear friends, let me introduce each of these reactions and we will discuss the answer accordingly. Ozonolysis is a kind of reaction of alkene which can produce aldehyde and ketones, and it's a very good conversion for converting alkenes to the aldehyde or a ketone. Now it will produce aldehyde or a ketone, it depends on the starting material of alkene you have taken. So the correct answer for the ozonolysis product is aldehyde ketone. Now when we talk about the complete combustion reaction of alkene, it will produce carbon dioxide and water. In fact, complete combustion of any of the hydrocarbon will produce carbon dioxide and water, while incomplete combustion may produce carbon monoxide or carbon itself. When we talk about the oxidation with Bayer's reagent, it will produce glycol molecule, that is the two hydroxyl groups are present on the neighboring carbon. So the correct set of answers are present in the option A, that is aldehyde ketones, carbon dioxide and glycol, and the correct answer for this question is option A. Hey friends, I hope you enjoy the show. Now it's a turn to get add to brain points. Our very first add to brain point is that reactions of alkene, and very important in the reaction is Markovnikov's rule and anti-Markovnikov's rule. Second add to brain point is to understand geometrical isomerism and associated properties. And third important add to brain point is that physical properties of alkene and their applications. So if you prepare these 3 points, you can easily crack various questions asked in the JEE, NEET and other competitive examination. will be coming on Thursday with a new show. I hope you enjoy the session. Crack the 7. Namaste.